In this video, we are going to discuss about SR flip-flop. SR means it is a set and reset flip-flop. For that one, file, go to new project, create a new Vivado project, give next, RTL project, give next, select the board as basis 3 board, give next, finish. So it is initializing the project. So go to this plus symbol, add or create a design source, create file, give the name as SR flip-flop, give OK, give finish, give OK. So now let us discuss the program for SR flip-flop. Module name is SR flip-flop. Output is Q and Q bar. Input is R and clock and reset. During the positive edge of the clock, if reset is equal to 1, Q goes to 0. Else begin case SR values. Say SR values 0 0 means Q is equal to Q, there is no change. If it is 0 1 means Q is equal to 0, okay, because reset is 1. If it is 1 0 means set is 1, so output is 1. If it is 1 1 means Q is equal to X, don't care value. Okay, next we can assign the Q bar values equal to not of Q. So let me copy this one and paste it here, and I'm going to save this project and run the synthesis. So the synthesis design is running. Okay, let me click the run implementation. So it is initializing the design. So implementation completed successfully. So open the implementation design. Okay, go to IO ports, Scala ports. So change this one to 33, and this one is W5, and this is L1, and this one is P1, and what is let me take this one as W2. Okay, and this is R2, and this one is T1. Okay, so let me save this project. Go to the source, check this one. So assign the values for clock, Q bar, and W2, R2 and T1 pin, R2 T1 pin. So it's correct. So let me go to create a simulation source. in order to check the input and outputs. So here only we are going to write the test bench program. So module test bench name, Q and Q bar is my output. So it was written as wire, and the inputs are SR, clock and reset. So this is the name of the previous program, DUT Q bar SR clock reset underscore N are the inputs and outputs of the SR flip-flop, and this Q bar SR clock reset in refers to this one. Initial begin when clock is equal to 0. Forever after 10 nanoseconds the clock becomes 1 and it will change, okay, after 10 nanosecond. And the initial begin reset is equal to 1. After 100 nanoseconds this becomes S is equal to, I'm giving some random values, okay. After reset is equal to 0, I'm giving this values, okay. So let me copy this program and paste it here. Save this project and run simulation and behavior simulation. So it is executing the elaborated step and executing the, so let me expand this one, okay. You can see, so initially reset is 1. So if reset is 1 and I have to check the clock during the positive edge of the clock, reset is 1 means Q is equal to 0, okay. And I can now see this one, so here also reset is 1. So if reset is 1, output is 0, okay. And let me come to this point. So here reset is 0, and during the if it is 1 means SR is 1 means it will go to X state, right? Okay. So here at this point, so this yellow line, vertical line, during the reset is 0 and during the positive edge of the clock, S is 1 and R is 0, so the output goes to 1. If you check this point, so here reset is here R value, that is reset is 1, so output goes to 0, okay. And so here you can see it is 0 0, so it will remain in the same state, okay. There is no change, the previous value remains same, so it's working properly. Now let me go to the source and generating the bit stream. It is initializing, running root design, then running write bit stream, then write bit stream get completed. Click open hardware manager, open target, okay, auto connect, program device. So SR flip-flop is my program, so I'm just programming this one, so it get programmed, okay. Initially the reset pin is 0. We are going to make the reset pin to 1. So if the reset pin is 1, whatever the change if I made in S and R, it will not reflected in Q and Q bar. Okay, you can see this one, right? Whatever the change, that is not reflecting in the output. So I'm going to make the reset into 0 now, and yes, I'm going to make it as 1. So Q becomes 1 and Q bar becomes 0. And next I'm going to make this to SR to 0 1. So the output goes to 0, Q goes to 0 and Q bar goes to 1. So if I make to 1 1, it will be a unknown state, right? Uncertainty, right? So next uh, if I change it to 0 1, output becomes 0 1, right? So if it is 0 0, it will be in the no change state, right? In this video, we are going to discuss about T flip-flop. For that one, file, new project, create a new Vivado project, project 43, RTL project, click next. I'm going to install in Basis 3 board, finish. So go to add or create design source, create a file name as T flip-flop, you finish. Okay. So let us discuss the T flip-flop program. Module name, input is clock reset in T, Q and Q bar. Input T is my input T, output register Q and output Q bar. So during the positive edge of the clock, always at the positive edge of the clock, begin if reset is 1, Q is equal to 0, else begin Q is equal to T. This is called as conditional statement. So if T value is 1, okay, um, if T value is 1, okay, the T value is 1, Q bar will be um, not of Q. This is not of Q. That is, Q bar will be executed. Okay. So mm, so I can see if T value is 1, T value is 1, what is the next state value? The next state value, this is nothing but Q plus. The Q plus value is equal to not of Q. Okay. So if it is 0, what is Q plus value? Q plus value is equal to Q. If T is equal to 0, you will get Q. So it is nothing but a conditional statement. End is for begin, and this end is for this begin. Assign Q bar is equal to not of Q, end module. So I'm going to copy this program and paste it here. Save the program. Then run the synthesis. So let us go to the IO ports, go to the scalar port. So change this one to 33 and W5 is my clock value. So default value. So Q is nothing but L1 and Q bar is T1, P1, sorry. Reset min is W2. In the input side, giving T values R2. It's not R1, it's R2. Change this one to LV CMOS 33. Save this project. I am giving some name as count. Okay, let's go to the source and check, verify whether it is correct or not. Generate bit stream. running synthesis of initializing the design. So certainly it will take some time. Running the design, running write bit string. So the write bit string get completed. Go to the open hardware manager, open target, auto connect. It is connected to the servers. Make sure the board is connected. Go to the program device. T flip-flop is my program. Program the device. So now it get programmed. Okay. So you can see you have to connect the basis board using that probe to CPU, and you have to assign you have two input pins. One is reset and D. Clock is already there in the basis board. Okay, so the clock is of very high frequency. So you have two outputs. One is Q and Q bar. So here you can see this W2 pin is 1. So if I change the value of T, it will not give any values. So whenever the W2 pin is 0, if I change the input to 1, it will is toggling. Okay, it is continuously toggling. So you can see two green lights are blinking. Okay, if I go to 0, it go to 1 0. So let me go to the source, add or create a simulation source, create file, go to test. Test is name of the test bench program. Give yes. So double click the test program, copy and paste this one. So here module TB is the name of the file, register clock reset, register T, wire Q, Q bar, T flip-flop, D flip-flop, initial begin clock is equal to 0 for our clock for 10 nanosecond clock is changing, give end, initial begin reset value is equal to 1 and display this value, and after 30 nanosecond reset value is equal to 0, so display this value, and T is equal to 0, and just giving the since the reset pin is equal to 0, whatever the change in the T will reflect in the output. So I'm giving these values, right? Like after 12 nanoseconds, it is T is equal to 1 to this value, giving the end and end module. So now I'm going to run the behavioral simulation, giving the yes. Okay. So it is executing the elaborated step. So I'm going to expand this one. So you can see initially the value, the yellow vertical line, one is reset is 1 at the clock value at the positive edge of the clock, Q goes to 0. So next to positive edge of the clock, reset is 0. So what will happen, the if T is equal to 1, it get toggled. Okay, the previous value get toggled. So previous value is 0, so now it goes to 1, Q goes to 1. If now if T is equal to 0 during the positive edge of the clock, it will remain in the same state, right? So initially it was 1, now also it is 1. So now T is equal to 0, so again it will remain in the same state. So here T is equal to 1, so it is toggling, right? Q goes to 0. Previously it was 1. Now it is going to 0. So since the value of t is 1, it get toggled. You can see that. Okay. So initially it was 0. Now it is going to 1 since the t value is equal to 1 during the positive edge of the clock. You can see previously it was 0. Now it is 1. So it is toggling, right? Q values get toggled.